Right, so it's really important to understand that if we are starting with a primary alcohol, we've got these two possible products from this type of reaction. Now, the substance that we add to the alcohol to turn it into either the aldehyde or the carboxylic acid is the same. Okay, so you use a particular substance to do reaction A or reaction B. The way that you control whether or not you stop the reaction in the middle and you get the aldehyde, or whether you go both stages and you end up doing reaction B and getting the carboxylic acid, is by the way the experiment is set up. Now, hopefully you're familiar already with this process, distillation, simple laboratory distillation. If you want to stop the reaction after the aldehyde has formed and not allow the aldehyde to convert into the carboxylic acid, then this is the type of experimental setup that you do. So this reaction here, or this process here, showing distillation, is what you do if you want to do reaction A. Now, hopefully you're familiar with distillation already. As I said, I've got it here as a diagram and also in a more kind of, realistic pictorial form. Normally I would get this stuff out in the lab to show you, but obviously I can't do that at the moment. I will direct you to a YouTube clip of somebody doing the same reaction that I would normally show you in just a moment. But for now, let's just go through the pictures. So you can see here that what you've got is your reaction going on in this flask and you're heating it from the bottom. Now what's going to happen is initially the alcohol, the primary alcohol that you've got in there, is going to react with something called an oxidizing agent. Now the first thing that forms is the aldehyde. Now the trick, if you want to just get the aldehyde and not get the carboxylic acid, is you remove the aldehyde as soon as it has formed. Now the aldehyde has got a lower boiling point than either the alcohol or the carboxylic acid. So if you do a distillation, then what you're doing is you're providing a condenser, so an area which is cooled by cold water, which goes in at the bottom and out at the top, and just flows around the outside of the apparatus just to cool it, okay? So the water doesn't go into the inside of that tube, it just flows around the outside to cool the apparatus down. So what happens is the aldehyde forms first, okay? It evaporates because it's being heated. It starts to condense where the apparatus is cold, and it's cold around here because of the cold water. And it condenses because of that cooling effect, and because of the way that that condenser is tilted, it means that when those liquid droplets of the aldehyde form, they drip down and are separated from the rest of the reaction mixture. So you separate the aldehyde as soon as it forms, and it can't turn into the carboxylic acid because it's been removed from the reaction mixture. So that's what you do if you want to do process A and stop the reaction at the aldehyde stage. However, if the carboxylic acid is your target, if that's what you want to produce, then we do a different experimental setup, and it's a process called reflux, which is probably one that you haven't heard of before. Now with reflux, if I just lift this up, look, so you can see again, I've got the diagram of it and a kind of more pictorial image underneath so that you can visualize it a bit better. In this setup, we've got a way of heating, which could be a Bunsen burner. Here it's shown as a heating manual. And in the flask, you would have the primary alcohol to start with. But this time what you want to do is you want to expose that alcohol to the oxidizing substance for as long as possible, so that when the first thing that forms, which is the aldehyde, it doesn't disappear and get separated. You want it to go the next step and turn into the carboxylic acid. So what this process does is, as it heats, then obviously the aldehyde forms first and it evaporates and turns into a gas, and it would start to rise up into this area. Now you can see here that we've got a condenser, but this time the condenser is in a completely different position to what it was when we were doing the previous method, the distillation. Here, the condenser is in a vertical position. And what that means is that as the vapours form and they start to rise up into this area of the apparatus, this is just open at the top here, but they don't escape, because what happens is they condense on that inside cold surface and they drip back down into the reaction, where they can continue reacting and convert into a carboxylic acid. And that process is known as reflux.